Hopefully the tariffs are double.
Can you remember how far we got in last week's class? What did we do last week? Very organised. And that was topic 4, was it, or topic 3? Topic 3. Collision, okay, that's topic 4. Okay. So we kind of, we finished. Yeah. How many weeks of holiday do we get? 4 weeks. Okay, that sounds like oh yeah, we did. Yeah, we spent the whole week, whole top. Yeah, okay. So we've done topic 4, so we're on topic 5. So we're a little bit. We wrote your exam paper last weekend. We had our deadline for submitting them.
Final exam papers.
Yeah. It's crazy, we have to write the final exam paper at this, a week and a half ago I had to write them. And I don't know what I'm going to cover at the end of the course. I was kind of hoping that maybe at the end we'd do one more topic than we did last year, but clearly I can't risk that in sending the exam paper. So it's really stupid. Okay, so the exercises from the topic 5, price discrimination. There were some on this linear demand example slide. I don't think there were any before then. Well, yeah, there was one, but it wasn't very interesting. What about this one? Oh no, yeah, actually there was a linear example earlier with 2-part tariffs. Maybe we should do that one first. So slide 16, just after the slide with the graphs, was this slide with the 2-part tariff of high types and low types. Did anyone have a go at that? You've had more time to do the exercises this week. Okay, so we had, it was QH is that 0,1 minus P and QL is A, oh, no, and the exercise said, does the firm always want to sell in both markets? Okay, so the firm was offering a tariff which was total cost of buying Q equals F plus PQ. Okay, and then the question, well, if a firm does sell in both markets, then both the high type consumer and the low type consumer pay the fixed cost, so the profits are 2 times the fixed cost plus, let's call this pi b, so pi sell in both markets, plus price minus cost times quantity. Okay, quantity is those 2 things added together. So it's 1 plus A minus 2 times P. So that's just on the slide. So that's for profit if they sell in both markets. And we showed in the lecture that firms wanted to set price equals C plus 1 minus A over 2. Okay, remember we showed that in the lecture? So if you substitute that in, and also we had that F is equal to A minus P all squared over 2. Okay, that was the optimal F because it was the consumer's the surplus that consumers would get in the absence of the F. Okay. That was making consumers just indifferent between buying and not buying, or making the low types indifferent. Okay, so substituting in, this is a minus p squared plus p minus c times 1 plus a minus 2p. Okay, substituting this in. So p minus c is this bit, a minus p is a minus c minus 1 minus a over 2. So what's that? We've got minus minus, so we've got plus half a here. So this is 3 over 2a minus c minus a half. Does that look right? Okay, so we've got that thing. 3 over 2 a minus c minus a half all squared. P minus c, which is just that, 1 minus a over 2. And then we've got 1 plus a minus 2 times p, so 2c minus 1 plus a. So this is quite a messy expression, which is why I gave you numbers to make things easier. So this is the profits if they sell in both markets. Let's just quickly write down the expression for their profits if they sell in one market. And then I think it's easier just to substitute numbers there. So if they just sell in one market, well, they're just going to sell to the high types. Okay, so if you're just selling to the high types, what are you going to do? Well, you've got a picture like this, right? You're selling some price. So this is 1. So consumer surplus is 1 minus p squared over 2. Right. So if you were just selling to the high types, you'd set T of Q would be equal to 1 minus. What's marginal cost? We've got marginal cost of C, haven't we? So, and it's for standard thing, it's going to be optimal to set P equals C, right? If you're just selling to one type, you set price as marginal cost, so you get rid of all the deadweight loss. All welfare becomes producer surplus, so that's the best you can do. So the tariff is going to be 1 minus P squared over 2. Oh, sorry, 1 minus. Okay, 1 minus your minus. That's the F. If you're selling just to the high types, plus C times Q, marginal cost times quantity. And your profits in that case, well, you only get one lot of F. So pi, just at selling to high types, well, you get F from selling to the high types. And then, well, here you've got a term that was like price minus cost times quantity, but price is going to be equal to marginal cost. So profits are just going to be the F bit. Okay, so profits are just going to be F, which is this 1 minus C all squared over 2. So the firm has two choices. It can either get this by selling just to the high types, or this by selling to both the high types and the low types. Okay, and I gave you some numbers to make things easier. I said suppose C is 0 and compare the cases when A is a half and A is 3/4. Okay, so if C is 0, then things simplify down a bit. So this is 1 squared is 1, so this is a half, and this is 3 over 2A minus a half squared plus 1 minus A over 2 times. What have we got here? We've got
2a minus 2c.
2, okay. So So that's going to cancel out the 2 there. So you get 2a minus 2c. Okay. So it's 1 minus a times a minus c. And c is 0, right? So just a. If c is 0.
Sorry, I don't know what, like, you've got +1 minus 1.
Yeah.
Oh, is that the, like, it's a plus, okay, sorry, I thought I saw a line.
Plus, minus, minus, plus.
Yeah, okay.
Yeah. My writing's terrible, clearly. Which is right. So this was, what did you say it was? 2a minus 2c. I could have done it a bit neater to start with. But when c is 0, okay, that bit drops out. Okay, so we just get 2a. The a cancels with that there. So then something not too messy. So you can actually multiply out the brackets here. So what's this? This is 3 over, so this is 9 over 4a squared minus 3 over 2 times a plus a quarter plus a minus a squared. Do you agree with my maths? So we get this thing squared, so 9 over 4a squared. We got 2 copies of minus a half times 3 over 2a. So the minus a half bit and the 2 cancel out. So that gives us minus 3 over 2a. Then we get minus a half squared, which is plus a quarter. And then we get plus a from there, minus a squared. So in total, what we've got 9 over 4 minus 1a squared. So take away 4, what's that? 5 over 4. So this is 5 over 4a squared. We can get rid of this there. Plus a. This is supposed to be a 4 here, you can't read it in the back. No, it's a 2, so 3 over 2. So this is like plus 2 over 2. So this becomes minus a half. So you didn't actually need to multiply out the brackets, we could have just substituted it at this point. So we've got this is now our expression for profits from selling in both markets when C is equal to 0. And what's it look like? What shape is it going to be? Well, it's a quadratic in A. When A is 0, this is going to be equal to a quarter. When A is 1, well then we get 5 over 4 minus a half. What's 5 over 4 minus a half? That must be, that's 2 over 4, so 3 over 4. 3 over 4 plus a quarter is 1. Okay, that makes sense, doesn't it, right? If you just sell to the high types, you get profits of a half. If A is 1, then the high types and the low types are actually the same, so it's just like your market is twice as big. So getting profits of 1 makes sense, right? So you just double the size of the market. So this makes intuitive sense. So when A is 0, this was equal to a quarter, which is less than a half. When A is 1, it was equal to 1, which is bigger than a half. So there's going to be some intermediate value of A, at which it goes from being smaller than a half to being bigger than a half. And in the question, I suggested you tried A as a half and A as 3/4. So if A is a half, then what do you have? So this is 5 over 4 times a half squared. A half squared is a quarter, so this is 5 over 16 minus half times a half, which is a quarter, plus a quarter, okay, which is 5 over 16. Well, 5 over 16 is less than a half. And then if A is, what was the other one, 2/3, I said? No, 3/4. A is 3/4. This is pi B equals 3/4 squared is 9/16. So 9/16 times 5/4. 9 times 5 is 45. This is a bit messy, isn't it? 45. 4 times 16 is 64. Is that right? Yeah. You've got calculators, obviously, in the exam, so you do this a lot faster than I can in my head. What am I doing? A is 3/4. So 3/4 times a half is 3/8 minus 3/8 plus 1/4. Someone want to do this on a calculator? Spare me the misery. 1/4 is like 2/8, so this is like minus 1/8. So we can make that minus 1/8. 1/8 is like 8/64. So this is 45 minus 8. 45 minus 8 is 37. Yeah. So 37 over 64. 37 is bigger than 32. So this is bigger than a half. Okay. So what have we shown? Well, we've shown that if A was equal to a half, then they would make profits less than a half if they tried to sell in both markets. Okay? So if A was equal to a half, they would strictly prefer just to sell to the high types. Okay? They would set this F to be a high value of a half, and at a half, the low types aren't going to want to buy at all. Okay? So we're only selling to the high types, but they make higher profit. Whereas if A was equal to 3/4, then they make profit bigger than a half from selling to both types, so they prefer that selling to the high types. So it's just kind of plugging in numbers. It's not actually difficult, right? If I had a calculator in front of me, your calculators, you can even assign letters to values, can't you, on these calculators you have? Can you store values in letters? You're allowed quite smart calculators, I thought. These Casio.
No.
You're not? You're only allowed stupid calculators.
No, scientific, but it's not allowed graphical.
Yeah, but in some scientific calculators, you have several different memory stores. Then you can't assign like A is 3/4.
I guess you can, you just need to know the procedure of doing it.
Yeah. So, you could do that, and then you could just type in this formula, and it would tell you immediately. It's probably easier to do it on a calculator than it is by hand, at least, however you do it. So. And you wouldn't know it's so difficult. I tend to give exam questions in which the answers end up being nice numbers, and the maths is never quite as messy as this in the exam. Spend a lot of, it's really hard setting exam papers. Setting problems where you're going to end up with a nice number at the end is very hard. I spend a lot of time just playing around with parameters until I find one which will give a nice number for the answer rather than square root of 7. Okay, so that was one question. Then there was a kind of similar question about third degree price discrimination. it's almost the same. So similar setup, but for third degree price discrimination. So quantity demanded in the first market was max 0, 1 minus P1. Quantity demanded in the second market was max 0, A minus P2. And total costs were equal to 0. So this is slide 24 here. Linear demand example 2 of 2 after is third degree price discrimination welfare improvement. This one? Looking confused?
The one that's empty.
Well, I did upload the fixed slides.
Yeah, that's fine. For now, it's
Okay, well, I'll write things on the board. It was just the PDF converter not working. Occasionally, words PDF converter gets confused. Is it one was empty? I thought I split it in two.
no, it's fine now.
Yeah, understand this. I split this slide in two. Somehow I saved the PDF, but I didn't save the PowerPoint, so I basically lost. So we keep the changes. Okay, so what did we found? We found that profits from selling both markets, this is what we found on the slide, were equal to without price discrimination. So 2 were equal to 2p times 1 plus a over 2 minus p. So that was profits from selling in both. Oh, actually no, we worked it out on the slide. Sorry, on the slide we substituted in the optimal value for p and we maximised and we worked out what it was equal to. We worked out on the slide that it was equal to 1 plus a squared over 8. Whereas if you just sell to the high types, then your profits were equal to a quarter. Yeah, we showed this in the lecture. So, you know, when are they going to want to sell in both markets? Well, just if this thing is bigger than that thing. So I suggested that you can just substitute in and then make a comparison, but let's do it a little bit more formally. So what do we need? We want to know where 1 plus a squared divided by 8 is bigger or equal to a quarter. Okay, so let's multiply both sides by 8, so that's 1 plus a squared is bigger or equal to 2. Okay, so what does that look like? Right, here's a is always positive between 0 and 1. 1 plus a squared is going to look something like that. Okay, and we want to know whether it's bigger or not than 2. So we don't have to worry about the second square root. Okay, because a is bigger than 0. No, this is just an increasing function. There's nothing funny going on with 2 square roots. Okay, so this is true if and only if 1 plus a is bigger than square root 2. So a is bigger than square root 2 minus 1. Okay, so the firm prefers to sell in both markets if and only if this thing is true. Okay, that wasn't rub this out. Okay, then the slide asked something about welfare with and without price discrimination. Okay, so let's draw our two markets. Okay, two separate markets. Here's one, that's one, that's one. Here's the other, this is A, this is A. And we've got some price. Okay. So with price discrimination, it's all quite easy, right? With price discrimination, we had price was equal to a half, quantity was equal to a half. Okay, let's write that. So if the price is equal to a half, then this triangle of consumer services and half. I suppose what we're interested in is welfare, right? Welfare is all of this. Yeah, welfare is the consumer surplus triangle plus the producer surplus square. Okay. So what's this shape? This is a what's it called? Trapezium or a parallelogram? I get the two confused.
Trapezium.
Trapezium. Okay, so the formula for the area of a trapezium is this distance times the average of these two distances. Okay, you get the same thing if you just add the area of a triangle to the area of a square. Okay, so with under discrimination we had P1 is a half, Q1 is a half. Okay, so welfare in the first market with discrimination, okay, is going to be equal to this distance, which is Q1, so that's a half, times the average of these two distances. Well, this one is just for price, which is a half. That one is 1, so half plus 1, all divided by 2. So that's our welfare in the first market, just welfare in the first market with discrimination. So half plus 1 is 3 over 2, divided by 2 is 3 over 4, divided by 2 again is 3 over 8. Likewise, welfare in the second market under discrimination. In the second market with discrimination, you have P2 is A over 2 and Q2 is A over 2. Okay, so again, look at this picture now. This distance is just for quantity. You look very worried.
Do I? Oh, sorry, it's my legs.
Is it okay?
I'm fine, it's fine.
Fine. You'll be fine. You know, everyone does well in the exam. Okay, so Q2 is A over 2. Okay, so we have, this is A. Yeah, this is Q2. So A over 2 times the average of these two things. So this one is P2, okay, which is A over 2. And this one is A, all divided by 2. So in total we have 3 over 2 times A, divided by 2, divided by 2, times A. So we have 3 over 8 times A squared. Okay, so total welfare, let's call it WT with discrimination. Well, that's W1, the welfare in the first market plus welfare in the second market. Okay, so in total we have 3 over 8 times 1 plus A squared, which is what the question said we ought to get. Okay, so that's welfare with discrimination. Welfare without discrimination, well, if a firm sells in both markets, okay, then they set a price equal to, what was it, 1 plus A over 4. Okay, so we can use, we're going to use the same formulas again, but now the prices are the same in both markets. Okay, so welfare in the first market when selling both, okay, without discrimination, but choosing to sell in both markets. Okay, well the quantity is equal to 1 minus, okay, so capital P is 1 plus A over 4 if you sell in both markets. This is what we showed. Okay, so Q1 is going to be 1 minus that, 1 minus 1 plus A over 4. This is hard. So what's that? So we've got 1 minus a quarter, which is 3/4. So 3/4 minus A over 4. Okay, so welfare, remember, it's quantity times 1, the average of 1, and the price. Okay, so the quantity here was 3 minus A over 4. And then we have the average of the price, which is 1 plus A over 4, and 1 plus 1 all divided by 2. Okay, so this is like 5 plus A over 4. Take that 1 up there, so that becomes 5. So 5 plus A over 4. So this is 5 plus A over 8. So this is 3 minus A times 5 plus A, all times 4 times 8, which is 32. Does that make sense? Okay, so welfare in the second market, when selling in both markets, well, Q2 is going to be equal to A minus 1 plus A over 4. Okay, so in total we have 3A minus 1 over 4. Okay, so the quantity term there is this, what we just had, 3A minus 1 over 4. And then we have the average of the price, which is the same as it was before, 1 plus A over 4. And the height of the trapezium, which was A, all divided by 2. Okay, so what's this? So this is, again, it's 5 plus A over 4, so 5 plus A over 8. So this is 3A minus 1 times 5 plus A, all divided by 8 times 4, 32. Oh yeah, you're right. I thought it was a bit further, I spotted. So we've got A over 4, and then we've got a whole other A. So in total we have 5A over 4 plus 1. Yeah, well done. Okay, so total welfare from selling both markets, well, it's the sum of these two things. Okay, so we're going to have something divided by 32, that looks right. We just have to multiply out these brackets and add them together. So let's do the a squared terms first, right? Here, a squared, we're going to have a minus sign, minus 1, and a plus 1. So in total we get a minus a squared from here. And from here we get 3 times 5a squared, so we get 15. So we have 15a squared minus 1a squared from there. So in total we have 14a squared. Okay, but then the a terms, well, we've got minus 5 from here, okay, from that combination, but then we've got plus 3 from here. So we've got minus 5 plus 3, okay, that's minus 2. So we get minus 2a from this one. From here we get 3, so from multiplying that and that, we get 3. Multiplying this and this, we get minus 5. So we get minus 2 in total. 3 minus 5 is minus 2. So in total we have minus 2 from here, minus 2 from there. So we get minus 4a. And then the constant terms, we get 15 from here, and we get minus 1 from here. So in total we have plus 14. Okay, all divided by 32. And that's what my answers on the slide say, so you can't make a mistake. So then the last case to do is just welfare when the firm decides to only sell to the high type. Okay, so if the firm only decides to sell to the high type, they set price is equal to a half, quantity is equal to half of that high type, and then welfare is just this. You know. So under price discrimination, you treat the two markets separately. So this was the welfare you got in the high market. Well, when the firm chooses to only sell in one market, they're going to do exactly the same as what they would under price discrimination when they're completely separate. So total welfare is 3 over 8 in that case. Okay, so if A is bigger than square root 2 minus 1, then the firm wants to sell in both markets. This is welfare. If A is less than square root 2 minus 1, then the firm only wants to sell in one market, and this is welfare. Okay, so whether price discrimination is welfare improving or not is going to depend on the value of A. And I showed you those graphs in the lecture, remember. Okay, so when A was small, the firm only sells into the high type without price discrimination. So when you introduce price discrimination, then the firm sells to both types, and welfare actually improves. Okay, whereas if A was big, without price discrimination, the firm sells to both types. With price discrimination, also sells to both types, but the prices are higher, deadweight loss is higher, so welfare actually falls. Okay, so price discrimination may or may not be welfare improving here, depending on how different the population is. Is this clear?
Can you repeat that again?
From the very
Just
start.
the conclusion. Just the conclusion.
Just for conclusion.
When
Okay,
A is
so
small, there's only higher types.
yeah, when A is small, the firm gets higher profits if they just sell to the high type. Okay, so the firm prefers just to sell to the high type in the absence of price discrimination. So if you allow price discrimination, well then the firm is going to sell to both types. Okay, suddenly these people, the students in the market can buy the good, and the fact that you're opening up a new market, that means that you're getting this whole chunk of extra welfare, and that means that overall welfare improves. Okay, whereas if A is very high, then without price discrimination, the firm chooses to sell in both markets, and because they have to set a price that's going to appeal to both the high type and the low type, basically set maybe a lower price than they would do if they were just selling to the high type. So you actually get closer to perfect competition. So welfare is actually quite good there. Whereas if you introduce price discrimination, then each market becomes like a monopoly, and you get a chunk of deadweight loss in each market separately. So welfare overall is worse. And the interest. Okay, remember some exercises from our shy. Did anyone have a go at these? 5.7, 3, 4, 5, 6. Okay, so 5.73 was almost the same as what we just did. Okay, 2 markets, linear demand curves. You know, it's just kind of what we just did, but with some numbers in there. So let's not go through that. Question 4 was a bit more interesting. Okay, so 4 it's a kind of similar setup. Okay, we've got P1 is 100 minus Q1 over 2. P2 is 100 minus Q2. Okay, we've got 2 markets, different demand curves in each market. Total production is Q1 plus Q2. Okay, the monopolist is selling in both markets. And what makes it interesting is that the total cost of producing that quantity, well, that's equal to capital Q squared. Okay, so there's some returns to scale. No, decreasing returns to scale. So maybe if they produce a lot, then their marginal cost is going to be high. So maybe this is going to make them more inclined to only sell in one market. Okay, so under discrimination, that's the first thing it wants us to do. Well, it wants us to write down profits. Well, profits under discrimination. Well, it's price times quantity minus total cost. So if we're going to be 2 terms, okay, so there's price in the first market, which is 100 minus Q1 over 2 times quantity in the first market, plus price in the second market times quantity in the second market, okay, all minus total cost, which is Q1 plus Q2 all squared. Okay, so the firm is going to choose Q1 and Q2 to maximize this expression. Okay, so they're not going to be independent because of this total cost term. So first order condition, d pi d dq1. Well, we get this times the derivative of that. Derivative of that is just 1, so 100 minus q1 over 2. And then we have derivative of this, which is minus a half times q1. Okay, so then we have another minus q1 over 2. And then Q1 doesn't appear here, but it does appear here. Okay, so we get minus 2 times Q1 plus Q2. Okay, so this is 100 minus Q1 minus 2 times Q1. So in total we have 100 minus 3 Q1 minus 2 Q2. Okay, then we've got the second market. First order condition for the second quantity. It's going to be very similar, so we get 100 minus Q2 minus Q2 minus 2 Q1 plus Q2. Okay, so in total we have so we've got minus 2 and then another minus 2, so we get 100 minus 4 Q2 minus 2 Q1. Okay, so what's the easiest way to solve this? So it's just two linear equations, okay? So you can solve one, substitute in. Sometimes it's easier to do something else. Let's multiply this equation by minus 2, okay? So this equation is equal to 0, so if you multiply it by minus 2, it's still equal to 0. Okay? So multiplying by minus 2, you get 0 is minus 200 plus 6 Q1 plus 4 Q2. Okay, so now let's add this equation and this equation. Okay, and the minus 4 Q2 is going to cancel out. Okay, so from adding the 2, we have 0 is minus 100, and then we've got minus 2 Q1 there, we've got a plus 6 there, so in total we've got plus 4 Q1. Okay, so Q1 equals 25. And then substitute 25 into either of these equations, we can get Q2. So if we substitute in here, this is 100 minus 2 times 25, so 100 minus 50. So this is 50 minus 4Q2 is equal to 0. So Q2 is equal to 50 divided by 4, which is 12.5. Does that work? 100 minus 4 times 12.5 is 50 minus 2 times 50. Yeah. Check this equation as well, check I haven't made a mistake. 100 minus 3 times Q1 is minus 75, so that gives us 25. Minus 2 times Q2 gives us the other 25. Yeah, so that works. Okay, so that's Q1 and Q2. That's what the question is. Okay, then it says, suppose now that a new management assumed control of the firm. The young CEO decides to decompose the monopoly plant into 2 plants. While plant 1 sells in market 1 only, and plant 2 sells in market 2 only. Calculate the profit maximizing output level sold by each plant. And then it wants to find out whether that increases or decreases profits. Slightly strange question. Okay. So the idea is, suppose we kind of duplicate the factory. Okay, we have one factory now that only produces goods for market 1, one factory that only produces goods for market 2. Okay, so the first factory, let's call it pi 1, is going to have profits 100 minus Q1 over 2 Q1 minus Q1 squared. Okay, and profits from second factory are going to be 100 minus Q2 minus Q2 squared. Okay, so it's as if we had two separate factories. And Okay, well the first order conditions now, d pi 1, dq1, so this is going to be 100 minus q1 minus 2q1. Okay, so this means q1 is 33.3, etc. Second market, 2 q2, we're going to get 100 minus 2q2 minus 2q2, so q2 equals 25. Okay, so quantity produced has increased. Well, it's kind of intuitive, right? Because here we've got decreasing returns to scale. Okay, so if you can duplicate the factory, you end up with two factories, each producing lower quantity. Two factories each with lower costs. Okay, so they're prepared to produce a bit more because they've got lower costs. And if you plug in and work out profits would be higher in this world than in that world. It's kind of unsurprising. So is this something that a company can do in real life? Well, it's quite expensive to copy your whole factory. So there's some big fixed costs to doing this. Another exercise that they might have asked you to do is say, well, suppose you had two managers, okay, and the managers are each trying to maximize joint profits, but they work in a Nash equilibrium between the two. So the manager of the first plant kind of takes the behavior of the manager of the second plant as given. Okay, then would you get the right thing? Yeah, you'd still get the same thing. I guess in some circumstances, I can imagine a circumstance in which maybe one manager isn't internalizing the fact that they're increasing the costs of the other manager, but you have to set up the problem a bit differently. As for question 5, there's price discrimination. So that was just kind of putting numbers to something we did in the lecture. Okay, they gave elasticities, and you had to work out how price was going to relate to marginal cost. Then question 6 was a bit difficult. I said it was difficult, so it's probably not worth going through. And then was 13.5 exercise question 1. Maybe we can do that. Okay, congratulations. You've been appointed to be the chairperson of the economics department at Wonderland University. Wow. Since that old photocopying machine broke down 3 years ago, the department has been deprived of copying services. Therefore, your first task as a chairperson is to rent copying services from Koskin Xeroxing Services Incorporated. The Koskin company offers you 2 types of contracts. The department can simply pay 5 cents per page, or the department can pay a yearly fee of $300 and in addition pay 2 cents per page. Okay, so this is tying. You're tying future purchases to a current purchase. And the question asks you to draw the department's total photocopying expenses as a function of the number of copies made. Okay, so one was 5 cents per page. So if you don't copy very much, that's probably going to be better. The other was $300 fixed charge and then 2 cents per page. Okay, so this is like inkjet printers, right? You pay for the ink. It's like laser. Oh, you're in here now?
Yeah, I think so. Unless they change something.
Okay, I'll stop.